Hello everybody, this is Gradius, and this is a video for solving absolute value equations by graphing. So what we're going to do is we're going to take equations that look something like this, absolute value equations that we've hopefully seen before, and we're going to solve these by graphing instead of solving them algebraically. Okay, so first what we did when we solved this absolute value equation is we solved it by separating it into two equations. So we would simplify it first by subtracting 1 on both sides, giving us 2 times x minus 3 equals 4. I would divide all of this by 2. I would have absolute value of x minus 3 is equal to 2. But then from here, I would separate this into two equations. I would have x minus 3 equals 2, x minus 3 equals negative 2 because of the absolute value symbols. That's how I get rid of it. So then I would just solve both of these by adding 3 to both sides, and I would get the values of x equals 5 and x equals positive 1. Okay, let me make this full screen. There we go, now I got more room. So that is how we solved absolute value equations before, and these are my solutions, which is a great way to do it. Okay, what we're going to do is we're going to look at a way to do this by graphing as well, just so we know both processes. So I have the graph 2 times the absolute value of x minus 3 plus 1 equals 5, same equation that we just did. What I'm going to do, though, is I'm going to graph the equation and pretend like this 5 wasn't there. I'm going to replace it with a y like we normally graph it, or an f of x. Okay, so I now what I'm going to do is I'm going to try to graph this first, and then we'll see if we can figure out our solution by using a systems of equations, and I'll show you what I'm talking about in just 1 second. So what I'm going to do, just the same process for graphing this. If you've not seen the videos for how to graph absolute value functions, please go back and watch those. Okay, so what I'm going to do is I'm going to graph this by finding my vertex. So my vertex is going to be 3, 1, based on my negative HK format. So 1, 2, 3, there's my vertex. Now let's use my slope, up 2 over 1. All right, so here is my graph. Perfect. So now what I want to do is I want to graph a second equation onto this graph, because really what's happening here is by replacing this 5 with a y here and graphing just this function, what we're essentially saying is that y is equal to 5. Okay? We're saying that by replacing this y with a 5, we're saying that y is equal to 5. Well, what I want to do is I'm going to graph the equation y equals 5. Okay, and that's going back to how to graph linear equations. When we graph y equals 5, we should have a horizontal line at wherever y is 5. So what I have is I have a systems of equations. What I have, my system is 2 times the absolute value of x minus 3 plus 1 equals y, and then y equals 5. And then what I'm going to do is I'm going to see where these two graphs, where they cross. And wherever they cross, those are going to be my solutions. Well, y equals 5 is going to be at 1, 2, 3, 4, 5. So here's y equals 5. And then really it's just a horizontal line right here at y equals 5. And if we notice, here is a point of intersection, and here is a point of intersection. Those should be my two solutions for x. And if we look, we'll have x is equal to 1, and x is equal to 1, 2, 3, 4, 5. So x equals 1 and x equals 5, because that is where this graph crosses. And let's see if this is the same function that we did on the first slide. Let's see if we have the same answers. X equals 1, x equals 5. Yep, it works. Okay, so the way to solve absolute value equations by graphing is we actually set up a system of equations. One's going to be a horizontal line. Okay, y equals whatever the whole absolute value function is equal to. And then we're also going to graph the absolute value function itself. So let's look at another one. So I have 3 times the absolute value of x minus 2 plus 1 equals 7. So I'm going to set this up into a system and then graph. So my system is y equals all of this that we had before. Okay, my absolute value function. So I separated that. And then because I'm replacing 7 with y, and I also have y equals 7. So these are the two functions that I need to graph, and then I just need to see where the points of intersection are, and those are my solutions. So I will graph this function right here in blue first. So y equals 3 times x minus 2 plus 1. So my vertex is going to be 2, 1, 1, 2, 1. And then a slope of 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. And I'll go the other way. And so that should be one piece of the graph. Now I'm going to graph my second equation, y equals 7, in orange. 1, 2, 3, 4, 5, 6, 7. Oh, it's right here. There's one of my solutions already. So there's y equals 7 right there. And now I can see my two solutions are here and here. So I need to see what the x values are. And that'll give me my solution to this equation. So x value is going to be 0 here. And it's going to be 1, 2, 3, 4 here. So x equals 0 and x equals 4. I am all done. If I wanted to check my solution, I could plug in x equals 0 over here and x equals 4 in here and make sure that they solve and they come out to equal 7. All right. Let's look at another one. So 2 times x, the absolute value of x minus 1, minus 5 equals 1. So the first thing I'm going to do is I want to set up a system of equations. So my first thing is I'm going to have y equals, and then I'm going to have all of my absolute value, all of this piece of my absolute value function. So I'm replacing the 1 with y. So I have 2 times, it looks like 21. There we go. X minus 1 minus 5. And because I replaced 1 with y, I also know that that means y is equal to 1. So here's my system. These are the two functions that I need to graph. So let's graph the absolute value one first, and then we'll graph my y equals 1, my horizontal line. So my vertex is going to be positive 1, negative 5. So positive 1, 1, 2, 3, 4, 5. Here's my vertex, and then my slope is 2, so I'll go up 2 over 1. I have to do it both ways because it's an absolute value graph. All right, so there's my absolute value function. There's a graph of that. Now I also need to graph the second piece, the y equals 1 part right here, y equals 1, which is going to be a horizontal line at y equals 1. And if you see my points, my solutions should be these points right here, because that is where y equals 1 crosses my absolute value function. So I just need to figure out what my x coordinates are. So I should have two solutions, figure out what my x values are, and those will be the solutions to this equation. 1, 2, so x is equal to negative 2. That's the x coordinate of this one. And x is equal to 1, 2, 3, 4. X is equal to 4. And there is my solution to this equation. Okay. Let's just do one more for practice. If you're good, you can go ahead and shut this video off. This isn't going to be anything new. Okay, but if you want to see one more example, please stay on and you can see this final example. So again, let's set up my system. Negative 3 absolute value of x plus 2 plus 6 is equal to y. And then let's also graph y is equal to whatever we replaced it with. We replaced a 3 with y, so y is equal to 3. Okay, so first let's start off with my vertex. My vertex is going to be negative 2, positive 6. 1, 2, 1, 2, 3, 4, 5, 6. So that's my starting point of my graph. Now what I'm going to do is I need to graph my slope. Be careful if you notice my slope is a negative 3. So because my slope is negative 3, instead of going up 3 over 1, I need to go down 3 over 1. Down 3 over 1. I need to do it both sides. Ooh, that was a terrible line. All right, let's try that one more time. That was not good. That one was not much better, but it'll work. Okay, so now I need to graph my second line, my second part of my systems of equations. I need to graph y is equal to 3 and figure out where my solution's at. So 1, 2, 3. So it's going to be right here. Here's y equals 3, and then therefore these are my two solutions, these 2 points right here, these x values. And so where they cross, let's see, x equal to -1, and then x also equal to -2, -3. And those x equals -1, x equals -3 would be my solutions to this absolute value equation. And that's it, you guys, we're all done. So the biggest thing here is I want you to set this up into a system of equations. Okay, so replace whatever this whole absolute value function is equal to, replace that with a y and graph it, and then also graph whatever you replaced y with, graph that value as well by making that equation as to y equals whatever that number is. And then where those two graphs intersect, those 2 points, those would be your two solutions for x. And that's it. So hopefully this video helped, and good luck, you guys. Thank you.